All right, guys, listen up. We're gonna go. All right. Um, last week, we in yep. Last week we went end the lesson with what?
I don't remember. It was some confusing stuff. Oh, we were doing n to the 0. So it's like the.
Okay. So I'll remind you a little bit. At 9.1, we have talked about the sequences, and before that, I also talk about like prior. Before this, we talking about arithmetic. Arithmetic sequence and geometric. So geometric sequence, yes, also recursive. Thank you.
Is recursive like the one where it goes a to the n plus?
Yeah, they give
A to the n plus 1.
Misha.
3 or a to the 2 is equal to a to the n plus 1.
Yeah, something like they will give it instruction. Just follow the instruction, type in each sequences. So we will start with the arithmetic sequence, geometric sequence, and the recursive. And we talk about the sequencing can, are they converge or diverge? If they oscillating, then it's going to be diverge. If they go into a value, it's converge. So after that, we did talk about monotonic. So what is monotonic? There's two ways to prove monotonic. One is the d to the dx, which is derivative, and do a number line test. Second is using compare to a to the n plus 1 versus a to the n. So we talk about two different ways to get there. And then when we start talking about series, we also talk about bounded. So bounded, what is it bounded? So that's 9.1. So this is all 9.1. But before that, we also talk about pre-calculus. So when we talk about pre-calculus, we talk about arithmetic sequence, geometric sequence. We talk about series, arithmetic, series, and I give you the series equation. Do you remember what's arithmetic series equation? Do you remember that? N times m an plus 1 over 2, right? Remember that? And we'll also give you a geometric series. SERIES. Okay, geometric series. What's the geometric series formula? Do you remember from? Yeah, so we're gonna talk about this one in particular. So this one we're gonna spend some time talk about this, and we're gonna lead to the geometric series because I didn't prove to you where the geometric series come from, but I do want to show you where they come from. So then 9.2 we start talking about series. Ben, you have a question? Can you ask me because I cannot? I don't know. You have a question. You are just talking to other person. I cannot talk while you're talking to other person.
Is there a formula for the?
No, they will give you so it's they will say 2a to the n minus 5, like 3a to the n minus 1, something like that. Or you just plug in that term and you figure out what is it. But they will give you instruction. You look at it. That's why I say we don't have a lot of homework. I want you to review the notes, and we want to keep on reviewing until you get better at this. Okay, what is series? Well, series is basically adding like s to the n is equal to summation of a to the 1 n equal to 1 to infinity plus a to the 2 plus a to the 3 dot 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 equal to infinite. And we start talking about what is the first series that we introduce? What is it? Telescope, right? Telescope series. And then after the telescope series, we show you example telescope series, which just looks like something like this. 4n squared minus 1, sorry, not like that. Summation of n equal to 1, infinity, and 2 to the 4n squared minus 1. And we say we had to do what? No, we cannot cancel. You have to do partial fraction. On the test, you're gonna see this. This is a very good test questions. For my tests, now for AP exam, I don't know if they do telescope, but I know competition they do telescope. So on your next test, Leonie and whoever go into the next one, you'll probably expect to see telescope, geometric, arithmetic, because by the time BC will get that far, and by the time the third test, you should have more series and sequence on that. So partial fraction. Why do we know it's partial fraction? Because the bottom is fractable. The bottom is fractable, then you had to immediately go to partial fraction. Do you guys still remember how to do partial fractions? Question? Yes, maybe? Okay. Aiden, do you remember how to do partial fraction?
Yeah.
Okay. So you have to be able to do partial fraction. Now, after that, we talk about geometric. Son of a... Who's yapping?
Do you know who?
I think this is so dumb of Apple TV. They should not have other people able to access other people's Apple TV. They should have to enter a password. Just like I send you an AirDrop, you have to enter a code now, and that's fine. They should have enter a code before they can log in my Apple TV. What a dumb. Okay, shh. If you guys have a question, please ask me rather than ask each other, because I cannot talk over you. I have my voice is limited. So geometric series, I can spell series, S-E-R-I-E-S. Geometric series, we know that one kind, but we never talk about how does this come in play. How is this come in play? So we have two definitions, by the way. The first definition is this, n equal to 0, infinity of, a to the r to the n, or I like this one too. So it's also a 1 minus r is equal to summation of n equal to 1, infinity a to the r to the n minus 1. So both are very good definition of geometric series. One is shifting 1 unit over, but your starting unit is also 1 unit over. Okay, but it's practically the same. So with that saying, we also say r has to be between where? Absolute value r has to be 1, right? So that means r is between -1 and 1. But r cannot equal to 1, because r equal to 1, then your number is going to get bigger and bigger and bigger each time. So your series will diverge. Let's talk a little bit about that. R. Give me an example, the biggest r that is less than 1. Okay. Okay, let's just do that, even that we do 0.9999. You say 5 nines, and we're going to say 999 like this, right? And you say 0.99999 is a very large r, but if I change the exponent a little bit, right? If I change the exponent to 999, now its number's going to get smaller. It doesn't matter what. If the exponents go to infinite, long as this is less than 1, it will still lead to become 0. Does this make sense? Long as they are less than 1. If it is less than 1, the power, this is not even a very large number. It's only like 9999999. It's not a very, very large number compared to infinity. Now imagine it goes to infinity. So it does not matter whatever inside the parenthesis. Ethan, ask me. Ask me. Don't ask Armin. Armin's smart, but I don't want to like talk over. I don't want to talk over you guys when you guys are talking. So ask me. You got questions?
No, I was asking Armor like something he said, but like it wasn't necessarily like.
No, it was I don't want to say it.
He was just saying that like he was gonna ask something because he was explaining that he sees stuff like this as like fractions, so it's like 1 over a number, something like that. I don't know. That's what he was explaining, but I didn't really catch what he was saying.
Yeah, don't worry about Armin.
Okay.
Armin just being Armin. Okay. So any question about the R has to be less than 1. And even negative, check out the negative number. If I put a negative here, it's still gonna give me a very small value, but approaching from the negative side, but it's approaching 0. So it doesn't matter they are positive or negative. So that's why it has to be absolute value R less than 1. But here's where they come from though. So a lot of people didn't understand where they come from. Not like you care, but Connor in 4th period says, I insist to know. So I go ahead and explain it. So I figure I explained to that period. I'm going to explain to this period. I thought it's actually pretty interesting. Now, so I was going to explain it anyway, not because Connor. So let's just say if I have the summation of the first term plus the second term plus the third term plus the fourth term plus dot 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 all the way to the second to the last term. Okay, second to the last term. So R to the n is the last term. Is that okay? So what I'm gonna do is I'm gonna take this function, and this is how math people come up with stuff. It's pretty cool. We're gonna multiply this by R. So it'd be R to the Sn. What will happen? A to the R, right? Plus A to the R squared, right? Plus A to the R third, right? Plus A to the R fourth. Is that okay? Mm-hmm. Plus dot 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 will be the last term. R to the what? And R to the n. Because n is a number that will go to infinity. You can put a limit in the front. So this is what happened. You multiply by R. So you multiply by R, it becomes R this. Okay. McKenna, you gonna focus on this? So if I subtract them, if I subtract 2 numbers, so today we would like to subtract. I'm gonna subtract this number with this number. So if I subtract those 2, what will happen if they subtract?
Oh, it would just be A by itself.
Is it?
A by itself and then A to the R.
Okay. You point out something very, very important.
Yeah.
Because what happened in the middle part of this region is like telescoping in some way. That's why we introduce you telescoping to let you see this. So this is going to cancel with this because you're subtracting, right? This is subtracting. So this will subtract this one. And then eventually this one to simplify this one. So the only term left is A and A to the Rn. Is that okay?
Yeah.
Now I can factor out S to the n equal to 1 minus R equal to A times 1 minus R to the n. And then I'll divide it over. Does that look familiar?
Yeah.
It's a formula in algebra 2. And what Banisha told me earlier is this equation. Right? So this equation is used to finite geometric series. That means R doesn't have to be between -1 and +1. It's a finite. That means I can use this equation to find any finite series. So we can show you example. I think we already showed it before. How do I come up with geometric series of 1, 2, 4, 8, and 16? And this is a sequence. So if we decide it, it'll be series, it'll be this. And we know that this is s to the 5. We know s to the 5 is this. But can I use the formula to get it? Yeah, of course. S of 5 is equal to, and your homework gonna have something this. This is a 1 times 1 minus 2 to the 5 over 1 minus 2. So regardless, this one's going to be minus 31 over -1. So the answer is 31. But if you add all this term, 1 plus 2 is 3, this 12, this 16. So it'll be 28, 23, just 31. So it's still equal to 31, regardless if I don't use the formula, if I add it by hand. Now imagine this, if I all the way to 8th term, then it's no longer adding by hand is probably feasible. You can do it with this way. But this is a finite geometric series. Is everything okay? Yes.
Wait, what made you know what A and R were?
A is the first term, R is the number you multiply.
Are we good here?
2 because it's 1, so AR is 1 and 2.
Ignacio is good? All right. Now pay attention to me. Now we're going to go to the next stage. How do we go from finite to infinite? Okay. So we can say we're going to take this. Brandon, put your phone away. I don't really want to take away you guys' phone. You guys are seniors, and except Ignacio, but you guys need to mature enough to like. I don't really care about a phone, but you guys also don't. I think that's a little bit too much. Okay, so now this is finite geometric series. Now remember, when we deal with this one, if r is bigger than 1, it's finite, it's fine. But if it's infinite geometric series, then this is where it becomes diverge. So then you say, well, since we wanted to have a infinite geometric series, the only thing we want is r is less than 1, right? So what happens when r is less than 1? For example, we're going to choose the r of 1/2 to the n. What happens when limit n approach infinity? It will lead to 0 because 1 over 2, so it'll be 1, 2 to the n, right? So 1 to the n stay the same, 2 to the n just increase larger and larger, so this will become 0. So guess what? This is how they become a equal to 1 minus r. Because r to the n go to 0. So this becomes an infinite geometric series. So at first we have finite geometric series, then we turn to infinite geometric series. Yes?
R only needs to be less than 1 in infinite series.
Yeah, in finite one because it's finite. So you can add up 5 terms, it's still going to give value. Even you add up first 20 terms, it's still going to give value. Even though value is going to be quite big, but still can sum up to things. So we start with the infinite, or we start with finite to all the way to infinite. But the infinite, the only required of infinite is r is less than 1. That's very, very crucial though, because later on you have something called radius of convergence, and it's very, very, very important. Okay, is that on the competition? Yeah. Yeah. So we will get there, but we haven't get there yet. But yeah, so there's a radius of convergence, and radius of convergence is gonna be used for like question like this or question like factorial and stuff like that, you're gonna find out it's very, very interesting. I know, like McKenna looks like same look as you have in Cooper's class. Like I don't give a shit about this. But trust me, if you guys build up right now, later on you're gonna see the very cool part of math. You might not be ever use that ever again, but I will say it's pretty interesting. So this becomes the infinite series. Yes.
So, like, how did you exactly get the infinite series? Like, you just kind of wrote it down. But, like,
Yeah, because this r, right? We say the r is less than 1, right?
Yeah.
Because we say infinite series has to be less than 1. So we can do 1/2, just say 1/2. 1/2 to the n. If the limits n approach infinity, this will eventually equal to 0. So does that mean this term will eventually equal to 0? If it's equal to 0, then there's just only 1 left. So it'll be a over 1 minus r.
So the r is equal to 0.
No, the r is not equal to 0. The r to the n will eventually equal to 0 if n is large enough. But since we're looking for s to the infinity, not r is, it's gonna be infinite. It's to the infinite power. So if you have anything smaller than 1 to infinite power,
Oh, correct. So r is like 0.999, and then you put it to the infinite power.
yeah,
right?
and it's still gonna go to 0. And that's the biggest r you can do because we can infinite geometric series. Am I losing anybody? Misha is like, I have no freaking clue what it is. Is it good? Are you sure? Everybody's okay before we move on? Okay. You more than okay? It's intuitive. I'm sorry. And the thing is about people that struggle in this type of stuff. What is going on? Oh, I don't know. Anyway, I don't know where to. I'll say. All right.
What?
So did we did a question of this one yet? Infinity of n equal to 1, 5 over 3. A to the n equal to 5 over 3 minus 5 over 9 plus 5 over 27. Did we do this one already? We did this one already? Okay, we're going to do the next one. We're going to show you another question that looks kind of interesting. So summation of n equal to 1, infinity e to the n over 3 to the n plus 1. So I want you to find out what is this geometric series end up to be. Our bottom is m equal to 1. So you had to use the definition for n equal to 1. Luke, you got it? You got a haircut, Luke? He's like, nah.
I think it's so little bald thing.
Ominous?
I don't know, because I just like, I split up the bottom.
You should go through that
to
into
the end, over 3 to the end.
enlightening.
And then I
How long is the
out
joke
of
gonna
it,
go on?
and
No joke.
it was. And it was kind of
The teacher never said that.
No, this is very long. Like, I split up the bottom. And then I forget the one third.
How many guys got an answer yet?
For which one?
For this one, for the next one. Because we already did the other one. Okay, what you get?
1/3 minus 1 over E.
1/3 minus what?
1 over E.
No. Yes, Safa.
I got E over 3 minus 3E.
That's correct.
Wait, 3?
I have 9 minus 3.
Same. Me and Lily got 9 minus
And then
3.
that becomes.
She said E over 3 parentheses 3 minus E.
Oh,
So that's practically the same.
wait.
And that becomes like. That becomes.
You-
You,
to me-
she's like 3 now.
Yeah, but no, but 3 minus E is also.
Because this is.
You guys have to understand this. What's going on? Do you guys understand or no?
Wait, can you write the answer down?
Starting off.
Okay, yeah, okay.
Do you get it? No?
Isn't that oh
Okay, so remember the definition looks like this, right? N equal to 1, infinity of A times what? R to the n minus 1, right? Is that okay? So technically, can I change this? N equal to 1 infinity, that's equal to 1 over 3 times E over 3 to the n. Does that make sense? Now, can I take out even more? Can I take out 1/3 and that's E over 3? Is that okay? Then it will be E over 3 to the m minus 1. Then what happened with this 2? This is my A, right? So n equal to 1 infinity, this is E over 3 squared times E over 3 to the n minus 1. So this is just to manipulate the exponent rules. Why did I keep this? Is this is 3 times 3 is 3 squared. You can. So in order to make Brandon feel better, it's E over 9. So we know that this is in the same format. So we know this format is A over 1 minus R. So it'll be E over 9, 1 minus E over 3. So in this case, it's E over 9, 3 minus E over 3. Is that okay? E over 9 times 3 over 3 minus E. This cancel out. 3. So it'll be 3 times 3 minus e to the e. Which is same answer is e over 9 minus 3e. Are we good?
Good.
You can do it other way as long as you get same answer. Do you guys understand or no? Yes.
So I kind of get when we start doing the a times r, we do the 1/3 times e to the 3. And right, if we just put an n because we already subtracted it by 1, right? Like the n.
So the whole thing is I'm trying to make this happen because since start at 1, I'm gonna make this happen like this. So I wanted to have a value, and I also want to have r value to the n minus 1.
Yeah. So you get this. Yeah, you can figure out the value. Then you just put an n at the top because.
I put n. I did not put n. I put a.
Oh no, a 1/3 times e over 3 to the power of n.
Where'd you get that from?
It's like the second top one.
Okay. Tell me when to stop. Right here. Where?
Up higher.
Here.
Yeah.
Okay. So what happened is this is 1, right? So can I say 1/3? So this is exponent rule, right? So it'll be 3 times. So 3 to the n plus 1. Can I write down as 3 to the n times 3? Yeah.
Oh, okay.
Does that make sense?
Yeah. Oh. And then that just automatically, like you figured out how to make it. And
Yes. Because I want an n minus 1 there. Are we good? Yes or no? Maybe. Okay, so 0.08 repeating. And we say, is it possible to make it to become fraction? Is it possible? Yeah, that's repeating decimal line. No. It's actually 0.08080808.
Oh, the lines over 0. I thought it was only all over there.
Yeah, how's that possible to make fraction? Well, can I write down 0.080808 dot is equal to, well, just look at the first term here. What is that? What is that fraction? A over 100, right? Does that make sense?
Why did you say plus 8 over 1,000, plus 8 over a million?
8 over 2.
And let's look at this one here. Oh, actually, we're not even worried about that. We just want to look at this particular, which is 0.0008. So it's plus what? 8 over not 10,000. Huh? 10 to the 4th. How's that 1,000?
It is 10,000.
10,000. That should be intuitive, dude. And what will be the next term? What will be the 0.08 here? 8 over what? 10 to the 6, right? So do you see a geometric series here? It's good. So this one I can start with, I don't know. Do I start 1 or 0? Doesn't matter. Oh, start with 0. Infinity. The first term is gonna be 8 over 10 to the 2, right? That's the first term. And for the next term, it's gonna be what? 1 over 10 to the squared n. Why? Because I multiply by 100 each time on the bottom. So since this is also this is 8 over 10, that's your first term. Divide by 1 over 10 to the square. This is, I think it's 99 over 100. So 100 cancel out. So my fraction is 8 over 99.
So why did you not have to make that n minus 1?
I could make it n minus 1. It's not a problem. It's a n minus 1. This one is equal to summation of n equal to 1. Infinity. Your first term is still gonna 8 to the 10 to the 2, right? Your ratio is still gonna be 2 n minus 1. Regardless, you plug in the first 3 terms, it's gonna get the same 3 number. Yes.
He meant to put n equals 0.
Yeah, so when n equals 0, it's
But if it's 1,
n minus 1.
Yes.
If it n equals 0, we have to show the proof of us making it n equals 0.
No, you don't have to show proof. Those two are same thing. Wait, it's a cut over? Oh, darn. I want to teach you one more thing.
You got 1 minute.
Challenge accepted.
Yes, 30 seconds. Let's be honest. Never mind 7 seconds.
30 seconds, correct.
You got no hope.
Go,
Mr.
go, go!
You'd be so proud of me. I played Eeny, Meeny, Miny, Moe at my physics test on Friday. I went Eeny, Meeny, Miny, Moe.
And what'd you get on the test?
I have no idea.
It's facing how it's on.
Minus 3. Minus 3.
We went to law.
Summation n equals 0, we're not going to the whole proof of n equals 1. So like the whole process for n equals 1 compared to the n equals 0 process where it's 8 over 1 minus 1.
They are the same. They just shifted, but you started at different value and then it's done. They're exactly identical.
So like the thing you just showed me was for AR n minus 1 because n equals
Don't do any more terms. Minus 3.
Bye. Bye. Trophy you guys won. Second one.
The calc scene, right?
No, that's the whole all the combined. Oh. That's like geometry, algebra 2. I thought the calculus won 6th place.
So we got Olympia got third place overall for all teams.
All team combined. Because we have a pretty good algebra 2 team.
I saw some team. I think I saw one first. Right.
Oh, OSS.
I thought it was one of our teams. I thought one of our teams got first or something, but no.
What did you say?
I think the highest we got was in algebra 2. That's what it says.
Yeah. Algebra 2 is good team. Calculus is good team. Geometry is not so good, but it's fun. We need pre-calculus. Actually, seminar are good. Not bad. Like in the middle, for like no practice, no nothing, just like go in there and wing it.
Three of the format of like their competition, I think. Like I think 3 of the 4 people on the department.
Yeah, particles that move in waves.
I still am, but I can't.
You're going to watch. Not sure whether I mean, what we
Unless it's cotangent and tangent. You not believe what I'm saying? It's both. Plus and it's all real numbers.
Yeah, exactly. That's
all right. So, I actually put the wrong one, but that's okay.
What?
That's exactly the same. Exactly the same. It doesn't matter. Ooh, I didn't know.
No, I
didn't do it. You know how to do it, but you have to know how to do it on the spot because you cannot possibly memorize everything.
I memorized the right height.
serious?
I put the wrong one, but that's okay. You guys don't remember anything.
But it didn't have anything on the graph.
No, you say 13-year-old. I was like, wait.
So on the last graph, however, I'm gonna write on a board. So on the last graph, so you're gonna tell me the equation for the last graph. So I will do that in a second.
No, we don't have to do anything, right?
Huh?
We're not doing anything.
You don't want to do x1, x2. Doesn't worry about it.
Okay, you gotta move forward, you gotta move back, move away.
You are this lazy.
When it gives you the scale, you like make your own scale, like with these. You just like do you put it where the point would actually be, or do you change the scale and make it? Like for example, if it's pi over 3, would you just like put it along with
This one, so
Mr.
oh, it's not.
Mr. Yes.
Oh, okay.
Do we say that X0 1, 2, 3, 4? Wait, no,
No.
that's two fits on it. I thought it goes off. Oh, I should have one.
Oh.
You said it goes back.
Yeah.
That's wrong.
oh, yours have food stain on it.
What?
Oh, well.
About 10%. You wanted to grab 1 or 2 pages.
If you can grab 2 periods, but some questions kind of long, we can have grab 4.
And you don't want to spread. Or out.
So not on the steps, on the next step, yes.
When you say mark scratch more than one period, do you want to mark like where the period starts and ends, or like it's fine? I just period each way, right?
What?
It's fine.
A period both ways, right?
What?
A period both ways.
You can, yeah, you can just do it all, just do the whole spectrum as much as you can. Don't miscount.